in today's topic, we are going to discuss about the Bohr model of hydrogen atom. Okay, so in last video we discussed about the Rutherford's model, isn't it? Rutherford's atom model. What is Rutherford's model? Yes, nucleus is at the center and the electrons are revolving around the nucleus in a particular orbit, isn't it? That is revolving around the nucleus. That much only Rutherford explained about the atom model, isn't it? So in Rutherford's atom model, nucleus is at the center and the electrons are revolving around the nucleus. So Rutherford explained his nuclear model using classical electromagnetic theory. When we were using classical electromagnetic theory, when we were using classical electromagnetic theory to explain this Rutherford's model, he understood that see, here in classical model, when the electrons are revolving around the nucleus, it will be losing energy. Okay, it will be losing energy. If the electrons are, as per electromagnetic theory, when it is revolving around in a particular orbit, it will be losing energy. This energy, if it is losing energy, what will happen? Whether it can stay in this the same orbit itself? No. What it will happen? It will be decreasing energy and it will be spiraling inwards and finally it will come to the nucleus itself. So stability can't be explained. Stability is not there for the nucleus in the case of Rutherford's model. Okay, as per Rutherford's model, if you are explaining classical electromagnetic theory, what will happen is electron will be losing energy continuously, and while it is losing energy, the electron from the orbit, it will be moving in a spiral manner because it will be losing the energy and will be coming more and more closer to the nucleus and finally it will fall into the nucleus. So we can't explain stability of the electron as per Rutherford's model. And one more thing, as per classical electromagnetic theory, see the frequency of the radiations. The frequency of the radiation emitted will be. Frequency of radiation emitted will be. So electrons are losing energy means it is emitting as radiation. Electromagnetic radiations will be coming out. Okay, so the frequency of the radiation will be equal to the frequency of the electron which is revolving. Okay, the frequency of the radiation will be equal to the frequency of electron. So the electron is coming inside. It is spiraling inside, isn't it? So the frequency will be angular velocity, and as per angular velocity, angular frequency also will be changing. Okay, so since it is more spiraling inwards, what will happen? Frequency of the electron and angular velocity according to that angular frequency also will be changing. So the emitted radiations will be changing continuously. Wavelength of emitted radiation will be changing continuously. See, the nu of radiation is changing. If nu of electron is changing, why it is changing? Because angular velocity is changing. If frequency of electron is changing, then frequency of radiation emitted also will be changing. If the frequency is changing, what will happen? Wavelength also will be changing. Wavelength of the electron also will be changing. Okay, if wavelength is changing, whether we will be getting a constant spectra for the particular hydrogen gas or hydrogen atom, if I am considering the emission spectra or absorption spectra, whether the wavelength will be constant? No, it won't be constant. So these are the dilemmas which we are obtaining in the case of Rutherford's nuclear atom model. Okay, so as per when we are explaining Rutherford's atom model using classical electromagnetic theory, as per electromagnetic theory, when it is moving, when it is revolving around the nucleus, it will be losing its energy in the form of radiations. While it is losing energy, the electrons will be spiraling inwards and finally it will fall into the nucleus. So it is questioning about the stability of the electron. Okay, so the next is frequency of radiation emitted will be equal to the frequency of electrons. Okay, if the frequency of electron, angular velocity of the electron will be changing when it is losing energy, isn't it? Angular velocity changing means its frequency will be changing. If frequency is changing, frequency of electron is changing, obviously that will be equal to the frequency of radiation as per classical electromagnetic theory. Okay, so if this is changing, frequency of radiation also will be changing. So then we won't be getting a constant spectra for hydrogen atom. Okay, so these are the actually it is not happening. We will always be getting a constant spectra. Okay, so this is the dilemma which has happened in the case of Rutherford's atom model. So next Niels Bohr came and he was doing some research in this Rutherford's lab itself. He did some experiments and he convinced that whatever this Rutherford explained is correct. So he understood that, but the as per classical theory, we can't explain all these phenomena like that he understood. So how we can give an explanation for correct explanation for Rutherford's model? If we are using like that, he was thinking, and if we were using electromagnetic theory, it is not at all enough. So what he did is he clubbed the classical theory and quantum theory also he used. Okay, so he had given 3 postulates for this electromagnetic model of atom. Okay, so that was well in agreement with the theory, the professor. Theory and all, it is very well it is doing very well with the theory. So that was an accepted model of Bohr's model of hydrogen atom. Okay, so Rutherford's model actually was correct, but we can't explain the Rutherford's model using classical electromagnetic theory. So using this, if we are clubbing the classical theory and the quantum theory together, we will get a correct explanation for our atom model. So that model is known as Bohr's model of hydrogen atom. So next we are going to study about this Bohr's model of hydrogen atom and what are his postulates. Okay. So next we are going to study about the Bohr model of hydrogen atom. So I told you what are the flaws in Rutherford's atom model, isn't it? Now that flaws, how we can recover that? Because Bohr understood that whatever Rutherford said was correct. Okay, so how we can give a proper explanation for that one? If we are using electromagnetic theory, classical electromagnetic theory, this Rutherford's model we can't explain properly. Okay, so Niels Bohr, what he did, he was clubbing classical model as well as electromagnetic theory as well as the quantum mechanics together, and he stated some postulates. So what are the postulates of Bohr atom model? So it's very important question. It's very important question. That is Bohr model. What are the postulates of Bohr atom model? Okay. So first flaw which we told about Rutherford's model is the stability of the electron. So it is losing electron energy and so it is coming inwards and coming to the nucleus and falling into the nucleus. That is what Rutherford told. So as per Rutherford's theory, electromagnetic theory, we can't explain that one. So Bohr stated that his postulate was like this: an electron in an atom could revolve in certain orbits without the emission of radiant energy. Without the emission of radiant energy. So there, if it is losing energy, then only it will come to the nucleus. If it is not losing energy, it won't come to the nucleus. It will stay in that orbit itself, right? So his postulate was an electron in an atom can revolve in certain orbit. It will stay in that orbit only without losing electromagnetic radiant energy. None of the electromagnetic energy it is losing. It is using it is without the emission of radiant energy, electron will be staying in its certain orbits only. So an electron in an atom could revolve in certain orbits without the emission of radiant energy. That is the first postulate. Okay, so second one. So the electrons will be revolving around the nucleus. So how it is revolving? An electron revolves around the nucleus only in those orbits for which angular momentum is integral multiple of h by 2 pi. So angular momentum should be equal to the radiation, isn't it? Frequency of radiation. Okay, frequency of emitted radiation will be equal to the frequency of electron which is revolving in the specified orbit. So the angular momentum is some integral multiple of h by 2 pi. So angular momentum of the electron which is revolving in the circular orbit, that will be h by 2 pi, nh by 2 pi. Electron revolves around the nucleus only in those orbits for which angular momentum is integral multiple of h by 2 pi, or we can say it is quantization. See, h by multiples of h by 2 pi only will be as angular momentum. In that, if those orbits which have multiples of h by 2 pi angular momentum, in those orbits only electron will be existing. That is his second postulate. So what was his first postulate? Electron will be revolving around the nucleus in orbit without emitting any radiation or radiant energy. Second one, electron will be revolving in orbits only in which have angular momentum and integral multiple of h by 2 pi. What is h? Planck's constant. That is what we discussed already, isn't it? About Planck's constant and what we learned. So next one is, an electron might make a transition from one orbit to another orbit. Electron will be moving from one orbit to another orbit, but only to the orbit lower than its previous energy. See, I have energy. See, I have 5 joules of energy. I won't go to 6 joules of energy. I can go to 4, 3, 2 or 1. Okay, I have 5 units of energy means I can lose energy. I can't gain energy from anywhere. I can lose energy and can go to the lower orbits. Okay, electron will be losing energy and will be coming to the another orbit by losing energy. It's losing energy. That means it will come only to the lower orbits. Okay, so while it is coming to the lower orbits, how much of energy it should release? It will be releasing 1 photon of energy. What is 1 photon of energy? H nu. Isn't it? So an electron might make a transition from one of its specified non-radiating orbit to another of lower energy, whose this transmission energy is EI minus EF equals h nu. So EI minus initial energy minus final energy equals h nu. So how much of energy will be released? 1 photon of energy will be released. So initial is the greater energy, isn't it? Coming to the lower orbit. So EI minus EF will be equal to h nu. That is the formula these are the postulate which Bohr had given. So the first postulate shows about the stability of the electron in a specified orbit without losing radiant energy. Second one states about the quantization of orbit. Okay, in which orbit it will be existing, whose angular momentum is equal to nh by 2 pi. Now, which are the multiples of h by 2 pi. Okay, in third one, it will always lose energy and will coming to the lower orbit. By losing energy, it will be losing an energy amount of energy which is equal to energy of photon. EI minus EF equals h nu. So clear these postulates. All these are very important. So next we are going to study about the energy of electron in hydrogen atom using Bohr's second postulate. Using Bohr's second postulates, we are going to derive the energy of electron in a hydrogen atom. So already we derived a formula using the Rutherford's explanation, isn't it? E equals minus E square divided by 8 pi epsilon 0 r. Electrons are bound to the nucleus, remembering, right? So in that video we discussed already. So but there the formula is E equals minus E square divided by 8 pi epsilon 0 r. Here E is a constant, all these are constant. Only r is the variable there. R is the radius of the orbit, isn't it? R is the radius of the orbit. So here, so to find out the electron energy, we should know the radius of orbit every time. So it is very little bit difficult, isn't it? So using Rutherford's model, that means Bohr's model, we will be finding out the energy of electron in hydrogen atom. Okay, so that one for that we are using the second postulate. Angular momentum is equal to mh by 2 pi. Using that one and some of the equations we will take from the Rutherford's model also. Okay, so shall I move to that? So next we are going to study about the energy of electron in hydrogen atom. What will be the energy of electron in hydrogen atom using Bohr's postulate? So first, using Bohr's second postulate. Using Bohr's second postulate, so what we can say, M is equal to nh by 2 pi. Okay, so but we know L is equal to mvr. So clubbing these two equations, we will get it as mvr equals nh by 2 pi. So if I am taking an nth orbit, I can write it as mv into radius of nth orbit. mvrn equals nh by 2 pi. So next is electron in a particular orbit will be obeying. Electrostatic force will be equal to the Coulombic force. Or Coulombic force is equal to the centripetal force. So what is the Coulomb electrostatic force? 1 by 4 pi epsilon 0 q square by r. Q square divided by r square equals mv square by r. So this is Coulomb force. 1 by 4 pi epsilon 0 q1 q2 by r square. So here 1r and 1r will get cancelled. We will get it as V square equals 1 by 4 pi epsilon 0 E square divided by mr. Like that we get it. Okay, V square divided by 1 by 4 pi epsilon 0 V square equals 1 by 4 pi epsilon 0 E square divided by mr. Like that we will get it. Okay, so here we are getting an equation for mr. See here from this is 1 and this is 2. Here I am from 1. See what is Rn? Rn equals nh by 2 pi into 1 by mv. So substituting in equation 2. And substituting that in this also we can write it for nth orbit. Okay. So substituting that in 2, we will get it as V square equals 1 by 4 pi epsilon 0 E square divided by m into 1 by Rn. So we should take the reciprocal and multiply. So it will be mv divided by nh by 2 pi. nh by 2 pi will be coming in the denominator. So we will be getting it as 1m and 1m will get cancelled. 1v and 1v will get cancelled. So we will get it as v equals 1 by 4 pi epsilon 0 E square divided by nh by 2 pi. Okay. Now we are going to substitute this value. This is equation number 3. Okay. Substituting 3 in 1. Okay. Then we will get an equation for Rn. So m into, instead of b, what we can substitute? 1 by 4 pi epsilon 0 e square divided by nh by 2 pi into Rn equals nh by 2 pi. Okay, so equals nh by 2 pi. Now if I am writing an equation for R, how I will be getting this nh by 2 pi will come here. So nh by 2 pi the whole square, 4 pi square divided by e square. So here I can write it as Rn alone, I will keep it here. So nh by 2 pi into nh by 2 pi will be nh by 2 pi the whole square. And the rest of the thing is 4 pi epsilon 0 should come here in the numerator. 4 pi epsilon 0 divided by, so m e square. So this is the radius of the orbit. So nh by 2 pi the whole square into 4 pi epsilon 0 divided by m e square. If we want to solve that, we can solve it as n square h square divided by 4 pi square into 4 pi epsilon 0 divided by m e square. So 4 and 4 will get cancelled, 1 pi and 1 pi will get cancelled. So you will get it as n square h square epsilon 0 divided by m e square. Okay, so this is the explanation for, this is the expression for finding out the radius of nth orbit. So now we are going to find out the total energy using the other equation. What is the formula for total energy? Minus 1 by 8 pi epsilon 0 e square by r. So if it is for nth orbit means En equals 1 by 8 pi epsilon 0 e square by rn. Okay, don't forget to put the negative sign. Negative sign shows that electron is bound to the nucleus. So substituting the value of Rn from here, we will get it as 1 by 8 pi epsilon 0 e square divided by n square h square epsilon 0 into m e square. Taking the reciprocal and multiplying, isn't it? So we will get it as 1 by 8 pi epsilon 0 m e to the power 4 divided by h square epsilon 0 into 1 by n square. Okay, so here 1 by 8 by epsilon 0 we know the value. Yeah, mass of electron is constant, charge of electron is constant. See, h is constant, epsilon 0 is constant. So we can substitute all these values and we will get the value as minus 2.18 into 10 to the power minus 18 divided by n square joule. So we have the rest of the things I am writing here. Energy we are getting it as minus 2.18 divided by into 10 to the power minus 18 divided by n square joule. Or in electron volt we are writing that is 111.6 into 10 to the power minus 19 we should divide. So minus 13.6 divided by n square electron volt. This is the energy of nth orbit. So energy of electron in the nth orbit we will get it as En equals minus 13.6 divided by n square electron volt. Okay, so this is the equation. Energy of nth orbit equals minus 13.6 divided by n square electron volt. So as n increases, what will happen? The value will be decreasing energy. Okay, so minus value minus 13.6 like that. So energy decreasing in the sense of, so that energy levels we will explain in the next video, because so that is the beauty of the equation. So that is what we will discuss. Now hope all of you understood this thing. I will tell you once more how we are finding out the energy of electron in hydrogen atom. First we will start with our both second postulate, m is equal to nh by 2 pi, equating it with the MBR, nh by 2 pi. And electrostatic force and coulombic force are equal. So we get it as V square. Okay, V square we are getting, and then Rn we are finding out. Then we are finding out the velocity equation, and then by substituting, then we got the answer as, and Rn we found out. Then using the equation minus 1 by 8 pi epsilon 0 E square by R, we found out the rest of the equation, minus 13.6 divided by N square. Okay, this is the formula too. So this is a important formula. Using this, we can find out the energy of different levels of orbit, and many numerical can come from this part. So in this video, we are learning about the Bohr's atom model and what are the flaws in Rutherford's atom model, Bohr's postulates, and then energy of electron in hydrogen atom. So hope all of you understood all those things, and please subscribe and share, and your doubts and all I'm expecting in the comment box. Don't forget to share it with your friends. Okay, thank you for watching. Bye.